pieces. And the ransomware pieces is interesting sort of in of itself and how it's playing out and how the decryption keys are sometimes not being handled properly or nobody's cashing out the Bitcoin wallets, etc. But the real meaty part of WannaCry and why it's such a bad thing is that it is the embedded worm that's in it. It's taking advantage of the previously unknown vulnerability in the SMB protocol to actually spread itself throughout your environment. So you could have hapless victims that get infected without ever double-clicking on the attachment in the email or without ever clicking on the bad URL. So there's watching this thing kind of spread is very interesting. And if anybody wants to see it kind of do that, we do have a video in our Cylance blog series. So if you go to cylance.com/blogs, you'll be able to see a video of the actual spreading between multiple systems of WannaCry. It's very interesting to kind of see that. But in today's example, what we're going to do is something a little bit more simple. We're just going to grab an example of WannaCry. Let's say I've got a few different variants here of the sample, and we're just going to execute it on the system. Now, this could have been weaponized coming in through an email attachment. It could have been a dropper from a website. It doesn't really matter how it gets on the system. There's still an executable or a DLL that's going to be executed on a system, on the victim system. And the interesting thing about this this ransomware piece is actually how fast it's actually working. Some of the ransomware that's out there, can take, a few minutes to actually, whack your system and compromise it. But this one is actually really fast. So I'm just going to execute this right now. And just in a few seconds, you're going to start to see changes occurring on the system. And even as fast as this is running in the background, if we try to open our PDF again, basically the PDF has already been encrypted and is essentially hosed. And so you can see very, very quickly, files being changed. Now there's the traditional, Windows wallpaper change. And within just a few seconds here, we're going to get the notorious WannaCry pop up here. And here it is, basically. But you can see really how fast it actually took out my sample files that I had sitting on the desktop. And so it's interesting to see. If you haven't had a chance to actually see it run live or have a chance to play with it in your own labs, I just wanted to kind of give you a quick understanding and a view of actually how this works. So we're done with our hapless victim now, and we're just going to kind of throw it away and let it reset. So let's switch over to a Cylance protected system. As you can see here on the bottom right-hand corner, Cylance Protect is installed. I've got the UI up so that you can see essentially, what's happening here. I've also bringing up Task Manager. There's a lot of questions around resource utilization, things like that. And on this system, what you can see here, the Cylance service is sitting at about under 70 megabytes of memory. And there's a little UI service that's running as well. It's the taskbar icon and things like that. Now this does spike up eventually, occasionally, depending on when it's logging in and checking into the console or other elements. But really, Cylance is really at sits on your endpoint at a fraction of the resources that a lot of the products out there today use, and still provides you with that level of protection that we have. Now, what I want to do with this system as well is that I want to illustrate the fact that we aren't doing some sort of cloud reputation service lookup or anything like that. So basically what I'm going to do is I'm going to start a ping session to show you that the system is currently connected to the internet. Now, this is important because a lot of products out there will call home or attempt to look up, samples in a known database, in a third-party database, their own databases, whatever. But basically, that's not how Cylance works. Cylance works fully autonomously on the endpoint, and that AI model that we keep talking about is fully deployed down on the endpoint. And so it can make its decisions autonomous, whether it's connected to the cloud or not. So what we're going to do is we're simply going to use this offline button here to literally change the default route an invalid IP. So we lose our internet connectivity. However, what I do want to also highlight here is that we still do have connectivity to internal resources like our Exchange server, for example. So I can ping this is the Active Directory controller server. I can still do things like, I can still do DNS resolutions, all kinds of good things like that, but again, I can't ping the internet. So I basically take this system offline. And again, it's important to see that Cylance can do its operations offline in a dark net, or if you have an outbreak and you run over and you disconnect the internet connection to stop exfiltration, or remote command and control or whatever. This worm, this WannaCry example is bad because the worm can still run if you're connected to your local network. It can still, attempt to infect your Exchange server. It can still affect the person sitting in the office next to you. So that's kind of one of the parts that's a little bit dangerous about this. So we're going to do basically exactly the same thing that we did before on the victim system, but this time we'll just go ahead and grab some more samples, and we'll just drag and drop them out here on the desktop. Now, some of the things that Tom mentioned earlier talk about our ability to prevent malware from running at pre-execution. So if I double-click on one of these samples, what you're going to see is you're going to see a Windows message saying that basically you no longer have access to this file, and it's because Cylance has, at the time that you double-clicked and told Windows to execute this file, we examined it and basically convicted and quarantined it and took it away. So we can do that. We can do it on this sample here, execute it and stop it. You can see us doing that. Now, I'm going to leave this sample on the desktop, not going to touch it, leave it alone. And what happens here is basically we have a feature called File Watcher that is going to pick this up at a later date and time. It doesn't necessarily have to pick it up right now. It's not doing anything malicious. Nothing is trying to execute it. So therefore, it is not necessarily a danger. It's a dormant danger, but it's not an immediate danger that we need to step in front of. So after a few minutes here, this sample is actually going to be picked up and taken away from the system, essentially quarantined by that File Watcher feature, looking low and slow in the background, picking up that change. Now, in the meantime, so we've convicted of the two samples there. We can even go back and grab some more samples. There's a whole bunch of other samples I have in here of samples that we downloaded from third-party sites, and I'll even, if I can here, click on the I can't examine or expand the window here for some reason. Maybe I can. Here we go. So here's, you can feel free to take a screenshot of this. These are examples that we downloaded from, third-party public sites. These are the actual hashes. If you search for them, you're going to find these. Again, we can, take some of these and drag and drop them out to the desktop, and they'll get, essentially picked up by Cylance. Now, that other sample has now disappeared off the desktop, and basically what you can see is that it was detected using essentially the File Watcher feature because it was a new file created on the system. We didn't attempt to execute it, but it's still sitting there, and it will, Cylance will then take it out. So these examples were taken out. You saw the pre-execution. There's no cloud connection, so we're disconnected from the internet, not able to do any sort of cloud lookup or third-party reputation service. But again, there's one more difference about this system, and it's really the important part, if you ask me, about what Cylance can do for you. And Tom mentioned it over and over again. He talked about other samples like GoldenEye and Zcrypter and these other things, about our ability to predict that something is going to be malicious. And this demonstration system that I'm using here today, besides being disconnected from the internet, has one more difference. And this version, 1320, is actually from the end of 2015 is when this is released to the world. So this version of our product that we're using here is actually over 18 months old from today. And you can actually see here, this is the actual math model file itself. artificial intelligence engine that sits on the endpoint. And this was produced in October of 2015. The product was released in early November, but essentially it's able to predict that malware because of the power of artificial intelligence and get you into a prevention mode that can actually work. Even, if you installed this product 18 months ago, took the system offline, put it into, an environment, never updated it since then, and then you threw a WannaCry example against it from last week, it will stop it just like you saw today. So that's a pretty quick demo, and I will turn it back over to Ed to take us through the end of the webinar as well as the Q&A. So please enter those questions, and we will get to them in just a few moments. Thank you. Ed?
Hey, thanks, Brian. Yeah, impressive demo. I think the